Hi guys, welcome to Easy to Learn. Now we are going to learn about what is a doubly linked list and what are the different kind of operations that we can perform on a double linked list.
Let us learn about doubly linked list, which is considered as the toughest program. But don't worry, I'll let you know how to think and enjoy coding. And I will also explain each and every statement. If you know this concept and you may feel bored while I am explaining the concepts which you already know. So please have patience and follow the concept. Right. I know the excitement that you can get after learning this tough concept. Now, what is a doubly linked list? The doubly linked list looks like this. And you can see the single linked list. A single linked list is like this bridge, which is one way. You can go only in one direction, but you can't go backwards. But whereas the doubly linked list is something like this, which you can travel both ways. So you can go to the next node as well as you can come back to the previous node. Now let's code. So this is our doubly linked list and this is how each node will be. So it consists of a node and we use the keyword struct. So this is how we code it and it consists of two pointers. One is to point which points the previous node, which we name it as prev, and which the other node which points to the next node. And it also consists of an integer data type such that we can store the value. Now you may get it out. Why this pointer node? Observe here, we have a variable and we need a pointer which points to that variable. So if I use float, then it will show an error. So we should not use float. And observe, this is the struct node. That's why my pointer is of type node. In C programming, this is how we code a node, struct node previous with an asterisk. But in C++, we can use or we can even avoid using the keyword struct. I hope you understood till this point. Now, node start. It always starts with a null. The starting pointer should always point to the null. Why? Let us see how it gets stored in the memory. First, the starting pointer points to the null. Then we will add the first node. Now the starting pointer is pointing towards the first node. Then it will move on and it will be connected to the second node. So that's why the starting pointer is very important. Without using the starting pointer, we can't access the linked list. Right. Now coming to the insertion operation. We have four cases here. The first case is to insert the first node in list. Basically the first node points to the null, later it points to the first node. The starting pointer is pointing to the null and we add our first node in doubly linked list. Coming to the second case. The second case is to insert the node at the end of the list. This is similar to an array in which we have new node at the end of the list. So the third case is to insert the new node after some node. For example, here I am trying to insert a black node after the blue node. So this is how it looks after inserting. So this is our updated linked list. The fourth case. The last case is to insert the new node at the beginning. That means at front of doubly linked list. Right. So if I code all these things in one function, it may be very confusing and complicated. So if you think all this concept is too hard, don't worry. I'll try to explain each and every statement as I have promised. So let us come to the code. So guys, now think. It is very difficult if we keep all these things in only one function. So I'll divide these into 4 functions or 3 functions here. So the first one is, in order to insert at the beginning, I simply used here, observe, in the beginning. So the function is add begin. Next, coming to the second case, in order to insert a node at the end, it is simply like any other insert operation. So I am using the function insert node. Coming to the third case, I want to insert after some node. So here I named it add after. So now in these 3 cases, observe that we are inserting a new node, but the position is different. It may be at the beginning or at the end or at the middle or after some node, but the code remains the same. So we'll ask the user where it should be entered. Right. So we'll create a node that is common for all. Observe here, we have created a node because in the 3 operations we should create a node. And here I also created a pointer and assigned that node to this pointer which is newly created. So now the pointer points to that node and we'll ask the user to enter the value, and that value is stored in the data. We use arrow to access the variable or pointer. Now the value of 10 which is provided by the user is stored in that pointer, and also the next and previous pointers of the point node is assigned with null, which means they are not pointing to anything else. Simple, we created a node. Now it returns the pointer. Observe the return value of this create node function is node star. So we return that pointer. So we are done with create node. Let us go to the next part, insert node. For this I have created a function insert node, and we can do 2 things. Insert the first node, insert a new node at the end. So to insert node at the beginning, I simply created a temp and assigned that node create node function to temp. It's pretty simple here. Observe, because the create node returns a pointer, I'll just replace that pointer with temp. Now the temp points towards the first node. Very simple. If start is equal to null, if the condition is true, then the temp is assigned to start. So basically the linked list starts with a start pointer, and in general the start is towards the null, but if the condition is true, now the temp points towards the starting. Now let us see how we can insert a node at the end. It is pretty simple here. Generally the start node points towards the first node. Our aim is to add this node at the end. Should we do any magic? Not at all. I'll use a simple logic here. Observe, we have a node called temp. The previous pointer of the temp should point towards the last node, and the next pointer of the last node should point to temp, and the next pointer of temp should point to null. That's it. Very simple. But there is a problem here. Can you guess the problem? Yes. How to find out the last node? If you can find out the last node, we can insert. That's pretty simple here. Observe what I'm doing. In general, we start from the first node, and for this I have created a pointer called traverse and assigned the starting node to traverse. And here I am using a while loop. While traverse of next means the next pointer of traverse is not equal to null, then traverse of next is assigned to traverse. What is this? Observe. It will just move on to the last node because the next pointer of the last node points towards the null. Very simple. So here, observe. So the traverse of next is assigned to temp. Now the temp previous pointer is assigned to traverse. That's it. We have successfully inserted. And you know, the node what we have inserted, the next node will point towards the null. Now the next thing is how to add after. So we have written a function called add after, and we used the temporary pointer and assigned the create node to temp, and we should ask the user where he wants to insert the node or after which value the data has to be inserted. So we ask the user to enter the value. Let us suppose this is the linked list and I want to insert a value between 20 and 30, and the value is 25. So let us see how we can do this. So here also I used a simple code in which I'll use a traverse and I'll use a while loop, and in that while loop I'll write a condition till that value is not equal to 20, you should traverse towards the right. So while traverse of next data is not equal to value, it should traverse towards the right. Yes. Now it reached 20. Now the next of 20 should point towards the value. And this is the toughest part. So I am taking some time to explain it further and in detail. So here we have 20 and the next node 30 and the temporary node 25. So all these nodes have the previous pointer and the next pointer. So now the things are very logical here. Observe. First diagrammatically, then I'll explain the code. So the temporary pointer of the previous pointer of temp should point towards the traverse because the traverse is at 20. Now the next pointer of temp should point to traverse of next. So 25 should point towards 30 and the previous of 25 should point to 20. Now the remaining two things. Traverse of next of previous. Is it confusing? No, please concentrate. So what happens here? Look. Now 30. The previous of 30 should point towards the temporary variable and the next of traverse should point towards the temp. I hope you understood this. The next one is display, which is the simplest of all. So this is the linked list, what I want to display. So we'll always start with the starting node. So I'll write while traverse is not equal to null, display the values very simple here. So it will display the values from the starting node to the last node. So the values of 10, 20, 30 and 40 are displayed. And the last one is delete. And deletion can be done in three ways. Delete the first node, delete the last node, and delete any node in between the first and last node. That means delete after some value. So in order to delete the first node, I have defined a function called delete big. So very simple here. The starting pointer. So we use the temporary variable and assign start to temp, and we simply point the next pointer of start towards the start. What does it mean? We simply increment the temp, and in order to free the memory, we'll delete the temp. So successfully we have deleted the first node. Now let us see how to delete the last node. So for this I have created a function called delete end. So I need to find out the last node. Simple. Once again I'll use the traverse pointer and assign it to start, and I'll use the same while loop. While traverse of next is not equal to null, traverse towards the right, so it will traverse towards the next. So traverse of previous will point to null, that is the value of 30. This node points towards the null. That's it. What should I delete? Yes, I'll delete the traverse node. Now obviously the next pointer of 30 should point towards the null. Very simple here. Now let us see how to delete after some value. Here we have the same linked list, and I want to delete a value 30. So what I do, observe the next point of 20 should point towards the 40, and the previous pointer of 40 should point towards the 20. Observe the code here. That's it. Now we will delete the temp in order to free the memory. Finally, everything is done. I hope you understood it well. Thank you.
Thank you for watching this video. Stay tuned for more updates and please do like, share and subscribe. Thank you.